Hi everyone, welcome back. Let's see synchronization mechanism without busy waiting solutions. Guys, you know synchronization mechanism is of two types. One will be with busy waiting solutions and another one will be without busy waiting solutions. So in the previous video we have already covered various kind of algorithms under the with busy waiting solutions, and also we have seen what are the various kind of problems that we are facing. One will be we are wasting the CPU time, and another one will be priority inversion. To overcome the priority inversion problem, we can just change the priority of the process which is there in the critical section so that this problem is eradicated, which means by applying the concept of priority inheritance we can overcome priority inversion problem. Fine. Then what about the wasting of CPU time? I have given clearly, that is using sleep and wake up system calls. Okay, means in general, if I say with example, if I am going to have a room here and there is somebody is already there inside the room, when I am entering into the room, I will check here as it is a kind of with busy waiting solution. When I check somebody is there inside the room, I will always continuously knocking the door. Continuously knocking the door, right? Yes. Instead, what we can do now? Instead, once you check a person is inside the room, and you observe that somebody is there, then you can just go for sleep. And you can sleep here, and after completion of the task by the person who is there inside the room, if he is coming out, he will come back to you and he will perform wake up operation, so that again you can enter into the room, right? Just think about the scenario. Are you really wasting the CPU time or not? Here you are not wasting the CPU time, because whatever the time you are getting, that time you are just checking at the entrance and will go for sleep if it is busy. If it is not busy, you can just enter into the critical section and you will use it. This is the example that will be comes under without busy waiting solution. Means if I have seen one process in the critical section, then what about the other process which try to enter into the critical section will go for sleep. Then the other process means the process which is present inside the critical section will come out and will wake up the sleeping process, right? So that I can able to enter inside the critical section, right? How this entire thing is going to be implemented? By using sleep and wake up calls. Okay, fine. So the simple solution to implement this synchronization mechanism without busy waiting solutions is with the help of sleep and wake up. We can say that system calls. Okay, then what is this sleep method? You might get question, right? The name itself is clearly providing sleep is a kind of a method which is meant for to block the process, and will be in the one queue, right? Once it encounters a sleep method, it will go for Q. will go for Q. If somebody is there, it will go for Q, right? Yes. Next one is a kind of wake up system call, which is meant for to wake up one of the blocked process. One of the blocked process, it will wake up. Means once it will encounter the wake up system call, it will go to the blocked queue. It will go to the blocked queue and wake up this person, and please use the critical section. Please use the room. That is what the meaning of this one. Okay, fine. So these are the two system calls that we are going to see, right? So to make it clear understanding of this synchronization mechanism without busy waiting solution, let me take a simple example which we are using in the real world, that is producer consumer problem without busy waiting. Guys, in the previous videos we already gone through the general meaning of producer consumer problem, and the algorithm also I have explained. The generally the problem what we are facing with the producer consumer problem is data inconsistency. If you remember the earlier class clearly, it will lead to the data inconsistency, where I have explained clearly with the algorithm also, right? Yes, fine. So anyhow, I will give the statement once again. What is the general meaning of producer consumer problem? Where the producer will produces the items and consumer will consume the items. Will consume the items by making use of a common memory. That memory we can generally call it as buffer here. Buffer, right? Means producer will produce the items into the buffer and consumer will consume items from the buffer, right? So here in terms of producer, I can say that this is one process, something like process P0, and this consumer is another process which I can generally call it as another process P1, right? Yes. So can I call this producer is also a kind of writer, and this consumer I can call it as a reader, something like that, right? We can make the scenario in variety of ways as per our problem, right? So means one process will writes the data into the buffer and another process will reads the data from the buffer. Okay, fine. So now let's look into the algorithm of producer consumer problem without busy waiting solution, and then we can analyze it. Hope you understood this video clearly. In the next video, we'll see the algorithm and we'll analyze it. Thank you.